Hi guys, welcome to the NumPy Essentials Practice Exercises Solution Notebook. So let's move on and try to answer all the questions and solve the given tasks. So in the first one, he's asking for what is the major difference between vector and matrix? Please consult the lectures. So the vector is actually a single row or a single column. However, matrix is multiple rows and multiple columns. How to import numpy library? This is a very simple task. Import numpy as np. And this is the traditional and common way of importing numpy. So in the next one, he's asking for convert the given Python list. So the Python list is given into numpy array and check its data type. So this is the result we want in the output. We are going to code here. Let's create an array ARR. What we used to do, we used to call array methods from numpy. So np dot array and pass in a list. We need to run this cell first. And he's asking for to print array and check its type. So what we are doing, we are passing the list to np.array and converting Python list to numpy array, and then we are printing array and printing its type. Let's run this code. Yes, so this is what he was asking. We got the same output. In the next question, he's asking for generate array 0, 1, 2, 3, 4, 5 using numpy's built-in function arange. So this is what we did several times in our previous lectures. So it's again very simple. np dot arange is asking for 0 to 5. So we want 0 and 6 because the 6 is excluded and we want up till 5. Let's print this one. Here it is. We have the same output here again. In the next question, he's asking for generate an array of 5 zeros. Zeros is a built-in function in numpy. Let's call that one numpy zeros. And how many zeros? 5. Let's pass in 5 here. Here it is. We have an array with 5 zeros. In the next question, he's asking for generate the following matrix. So the output is given. We have to generate a matrix with 3 rows and 4 columns, all zeros. So we are going to use these zeros again. But instead of passing 5, we have to pass the shape what we want. We want 3 and 4. We want 3 rows and 4 columns. Let's run this cell. So here it is, we have the same output again. In the next question, he is asking for generate 1.1.1 using numpy built-in function. So if you remember, we have learned about zeros and ones. We can use ones here. np dot ones. And how many elements we are looking for? 1, 2, 3, 4, 5. 5. So notice that we have array in the output. We need to pass in to print so that we don't see this out 7 here and we don't see array. So print is an official way of getting output in Python. Here it is, we got the output what he was asking for. So in the next question, he's asking for generate an array of 5 tens. So we need an array, each element should be 10. This is again a very simple task and can be implemented using ones. What we can do, we can copy here np.ones, and this will generate an array of 5 ones, and now we can multiply by 10, and here it is. We got an array with tens, 5 tens in our output. So in the next question, he's asking for use a range to generate an array of even numbers between 50 and 100. And the hint is 50 and 100 are not included. So let's use np.arange. We pass in 50 and 100. So we know this 100 is already excluded, but this 50 is included. He's asking for even numbers. We will start from 52. And now there is a third argument that we can pass. He's asking for even number, so we need to add a step, which is 2. Let's run this code. So here it is. We have 52, 54, 56 up till 98. This is the same output. In the next question, he's asking for generate an array of 10 linearly spaced points between 0 and 1. Output step size as well. So if you remember linspace function, we use that function to create linearly spaced points. Let's try that function here. np.linspace, and what he's asking for between 0 and 1. And the third argument is how many points we want. We want 10 points. So let's run this code. We have array from 0, 0.1, 0.2, between 0 and 1, 10 points linearly spaced. So one thing is missing here. We need step size as well. If you go to the doc string, we know we can print step size with ret step true. Let's copy this thing here and pass in as true and run this one. So here it is. We have the step size as well. So in the next question, he's asking for perform the following tasks. The first one is generate a vector array of 25 numbers using a range. And after that, write a code to convert the vector array into two-dimensional matrix using reshape. Can we use shape instead of reshape as well? Let's start with arr np.arange is asking for 25. So let's print this error. So here it is. We have 0, 1, 2, 3, 4. So the next he is asking for second task. Write a code to convert a vector array into 2D matrix using reshape. Let's convert this array into 2D matrix. If we know, we can pass in the shape here. If we look at the doc string, this is the shape. So we can pass in the shape, and what is our required shape? 5 by 5. So 5 and 5. Here it is. We got the same output. So the next task is, can we use shape instead of reshape as well? Yes, we can use shape instead of reshape. Let's try to use shape here instead of reshape. So arr dot shape equal to 5, 5. This is how we used to generate this is how we used to convert a one-dimensional array to two-dimensional array. So now here it is. So we have converted one-dimensional array to two-dimensional array it's using shape instead of reshape. In the next question, he's asking for, please generate the following matrix. So we want this matrix in the output. What we can do, we can simply generate a matrix from 1 to 25 and divide that by 10 to get the output what it is here. So let's try this one. np dot arrange, pass in 1 to 26. So we want 1 till 25 and 26 is excluded as we already know. Let's print this one how it looks like. Let's reshape this to 5 by 5. Now it looks like we are approaching towards the solution. If we divide this one by 10, here it is. We got the same matrix in the output. In the next question, he's asking for write a code to generate the output below. Use linspace and print. So we have to generate this matrix here. If you look at the output, we have 0, 1, 2, 3 up to 24. Let's use np.lin space 0, 0, 24, and we have 25 elements in this matrix. Let's run this thing. So we have 0 to 24. So we have 0, 1, 2 up to 24. In total 25 elements. So let's reshape 5 into 5. So we have the matrix here now. So if we look at this thing, he is using print statement and he is printing the step size at the end. If we put this one into a print statement, so we got the matrix here, and now we have to print the step size, and we have to write this string as well. So the step size is, now we know we can get step size from linspace, and if we pass in index 1, we get the step size. So this is what the output is looking for. So the next one he is asking for, what is the main difference between linspace and arange? If you remember, arange takes third argument as a step size. However, linspace takes third argument as number of points we want in the output. Like here we wanted 25 points between 0 and 24. So this is the major difference between arange and linspace. In the next question, he is asking for how to generate single random number using numpy built-in function. So this is again very simple. np dot random dot rand 1. So if we pass in 1, we will generate a single random number, and your answer may be different because this is random number generation. So in the next one, write a code to generate 7 into 5 matrix of 35 random numbers. So now we have to generate a matrix with 35 random numbers. So once again with np dot random dot rand, we can do in two ways. Like we can generate 35 numbers and then reshape to 7 5, or So this is what the output is, and he's using print here again. We can do another way as well, like np dot random dot rand, and we can pass in argument 7 5, so we can directly generate a matrix with 7 into 5 shape. So let's print this one here, and so we got the matrix with 35 random numbers. In the next question, generate the following matrix using numpy built-in method for identity matrix. So np dot eye5. So we got an identity matrix. We can multiply this by 5, and this is our output. Generate the following matrix array 2D and replicate the provided outputs. So now these are a couple of questions, 18a, b, c, and so on. Let's generate the matrix first. He's asking for array 2D equal to np dot, we can use a range, and from 0 to 29 we need to pass in 30 here, and then we can reshape to 1 2 3 4 5 into 1 2 3 4 5 6 rows and 5 columns. Let's print this matrix here. So this is the matrix we want. Next is we need to get the part, a slice from this matrix, 17 18 19, 17 18 19, 17 22 27, and so this part here. We can grab a part here like array 2D and then pass in. So we can pass in 1 2 3 3 and everything afterwards, and column 1 2, so it's 2 and everything afterwards, 1 2, and this one 1 2 3 and this one. So we are grabbing this section here. So here it is. In the C, he's asking for to grab 29. So 29 is this corner element here. If we look at the matrix 0 1 2 3 4, 0 1 2 3 4 5, so row 5 and column 4, what we need to pass in 5 and 4. So here it is. Now he's asking for this output here. Once again, and what we need to grab, so we need to grab 1 6 11. So what we can pass in everything, and then 3 and 1 2 2 and 0 1 2 0 1 2. Yes, so if we run this code here, yes, so we are getting 1 6 11. So the next one is he's asking to grab 10 11 12 13 14, 10 11 12 13 14. So 10 11 12 13 14 is third row in the column. So we can grab this third row array 2D 2. So row at index 2, and in column we need everything. Here it is. So in this one he's asking for 2 rows at index 2 and 3, index 2 and index 3. Let's copy this one here. Now he's asking for index 2 and 3, so we need from 2 up to 4, and 4 is not included. It will count 2 and 3 and everything in column. So here it is. In the next one he's asking for, can you calculate the sum of all the numbers in array 2? So yes, we can calculate the sum of all the numbers. We need to call dot sum here. So if we call dot sum here, it's going to return the sum of all the numbers in the matrix. Next one is calculate sum of all the rows and columns in array 2D. So now we need row sum and columns sum. Let's do this thing. Notice that we have to use the print statement here again. Print row sum is equal to, and then array 2D. We call sum on it, and now we have to call on axis. So the first one is row sum, so we call on axis 1. Let's copy this one, paste it here, and now this one is axis 0. So this one is column sum. So here it is, we have row sum 10, 35, 60, 85, and column sum. Next one is calculate the standard deviation of the value in array 2D. We can call standard deviation function on matrix array 2D dot std. It's again simple. Let's run it. So here it is. The last one is he's asking for create a Boolean mask and list out the numbers that are not divisible by 3 in array 2D. So first we have to create a mask. And what will be our mask? 0. We want divisible by 3. So any number, if we divide it by 3, we should get 0 if it is divisible by 3. So what we want to eliminate if they are not equal to 0. So 0 not equal to array 2D, and we want to know remainder 3. Let's print this Boolean mask just to see how it looks like. So here it is. To filter out the elements, we have to pass in this Boolean mask to array 2D. Let's comment it. So here it is, 1, 2, 4, 5, 7, 8, 10, 11, and this is what we need in the output. So guys, this was all about the solution part of numpy. I hope you got a very good understanding on numpy and its basic concepts. Once again, numpy is very important to move on in this course. If you think you need more practice, go ahead and revise this section. See you in the next lecture where we will learn another very useful Python library for data science. Good luck.